Hello, everyone, and thank you so much for joining us today. I am your host, Shireen Ben-Zayed. I'm head of innovation at Finastra, and we are welcoming you for our first live meetup in a series, part of our Hack to the Future Global FinTech Hackathon. Hack to the Future, as you might know, is a fintech movement igniting a world of financial sustainability, inclusion, and empowerment, way beyond just a single hack. So building on the success of our previous hackathons to redefine finance for good and build an unbiased fintech future, we continue to use our position in the market to inspire the fintech space to be open by default to everyone. And this year, we aim to drive engagement beyond our global fintech ecosystem with 3 key themes that are all inclusive and open to all. First one is sustainable and inclusive finance. Second one is embedded finance and banking as a service. And the third one is decentralized finance. And today we will be starting with theme 3, so DeFi, with a focus on blockchains and networks. And I'm really excited to welcome IV Yoo, who's our data scientist and computer engineer at Finastra. Hi, Ivy.
Hi guys, I'm Ivy. I work on the innovation team and I am really excited to kick off the first learning session.
So yeah, over to you, Ivy.
Okay, so today we're going to cover what makes each blockchain technology unique and why each one's cryptocurrency is priced and valued differently. So here's our agenda. So first, I want to introduce some history and draw some distinctions between the 2 most well-known, Bitcoin and Ethereum. And then I want to talk about the technology behind the security of the blockchain protocols. And then, so we can build a blockchain on top of a blockchain. So I'm going to talk about, these are called layer 1 and layer 2 solutions. So I want to highlight those and talk about some key differences. And at this point, we are going to have discussed the properties relating to the actual blockchain protocols and technology, but I want to talk about the prices of each cryptocurrency and what affects the valuation. And then lastly, I want to talk about some ESG impacts. So Bitcoin, let me talk a little bit about a background and a brief history. So Bitcoin was actually born after the global financial crisis in 2008. People started to begin losing trust in banks and other financial institutions. So what happened was there was kind of a double spending problem. So banks make money by taking your deposits and your money, and they take that and lend it out to other people. So what happened was they ran to the bank after the crisis and they tried to withdraw all their money, but banks weren't liquid enough. So then this individual or group of individuals named Satoshi Nakamoto, who actually disappeared very shortly after the birth of Bitcoin, he came up with this decentralized peer-to-peer cash system where people can send money to each other directly without using a bank or intermediary. And it's called decentralized because the data that is held is kind of spread out so that there are multiple copies of the same data. And the implementation, so there are thousands of computers that are collectively participating in the network. And it actually became massively popular as a payment utility in the Silk Road. Some things that kind of contributed to this was to use Bitcoin, you don't need a name, you don't need a birthday or any other identifying information. You don't need identification documents. You don't even need a bank account. It really works well for cross-border transactions. Settlement is finalized almost instantaneously, and there's a lack of clear regulations. So it just kind of fit as a really good payment utility. But now it's more used as a payment gateway in countries that don't have established financial infrastructure. And it's used as like a store of value and a hedge against inflation. And now people are calling Bitcoin digital gold, and they kind of have, Bitcoin and gold kind of have these overlapping characteristics. Gold is scarce. There's a really high demand for it. You can use gold as money to obtain other goods and services. Gold is very durable. It's fungible, which is means it's interchangeable. You know, if I give you an amount in like 10K gold and then you give me an amount in 24K gold, you can value it the same. Gold is divisible, and it's also verifiable. You can test the purity. So there's very similar characteristics, but Bitcoin has an advantage because it's very portable, because gold is very heavy, it's hard, and really expensive to store and transport, versus Bitcoin is intangible. So there's no, it's really portable. Okay, and then now let's talk about Ethereum. So Ethereum is actually the name of the blockchain, and the engine under the hood is called the Ethereum virtual machine. Now, what the Ethereum virtual machine does, it's capable of running code of any complexity. And Ethereum is kind of like a general purpose programmable blockchain. So it's kind of like a computer. So when you have a physical computer, the performance and what you can do with it is limited to your hardware, you know, your graphics card, your processor. But Ethereum is this like huge computing infrastructure that can run code of any complexity. So why use Ethereum and not a computer? Well, one, it's governed by the rules of consensus, so it's very secure, and its state is distributed globally. So there's copies of whatever you're doing everywhere. Now, the code that the virtual machine runs is called smart contracts, and the code is executed by this network of computers. So the virtual machine will run the code and then store the resulting changes in the blockchain. So now when you have the resources like of a global network, how do you ensure that people just won't take advantage of the resources available or accidentally run code that throws an infinite loop? This is where the cryptocurrency Ether comes in. So Ether is the gas. It's the fee that you have to pay to use the Ethereum virtual machine. And Ether, the gas fee is calculated by your complexity of the code, how much computing power you're using, how much resources on the machine that you're using. And it's paid in Ether. So Ether was not meant to be a peer-to-peer digital currency network like Bitcoin. Did I accidentally not? Do you still see my screen? I think I accidentally clicked out.
Yeah, I think we've lost your screen, Ivy. If you can please share again.
Oh yeah, I'm so sorry about that.
No worries. And also, as you're doing that, just a quick comment to everyone who's watching us either on YouTube Live or LinkedIn Live. Please post all of your questions on the chat, and we'll take them at the end of the session with Ivy.
Yep. Okay, so now I want to talk about the consensus algorithms.
Oh, we still don't see it, Ivy.
Oh, really? Okay, sorry. Give me 1 second. Okay, Shireen, let me know when you see it.
Yes, we've got it. It's back here. Thank you so much.
Okay, I'm so sorry about that. Okay, so consensus algorithms. So this is kind of what secures the blockchain. Now, the problem when you have thousands of computers in a distributed computing environment is, how do you reach consensus? How do you ensure that all of the computers can agree on what is happening? So all the peers that are participating have to reach a common agreement about the present state of the ledger. So essentially what these consensus protocols do is that they ensure that every new block that is added to the blockchain is the truth that is agreed upon by all of the nodes. Now, this does two things. First, it establishes trust between unknown participants, and it also discourages validators and miners from dishonest and malintentioned validators and miners, because you have to provide some kind of stake. And the stake is some kind of value that you have to put forward, whether that's your computing power, your crypto funds, or your reputation. So participants who are validating these new transactions in the network, they're not going to do this work for free. So to incentivize, there is a reward system. Now in proof of work, Your stake is your electricity, the computing power, and the cost of your hardware and machines. But in proof of stake, there is no specialized hardware or massive energy consumption. You don't really put forth external resources like electricity, but an internal one, and it's your funds. Let me back up for a second. Proof of work is the consensus algorithm that secures Bitcoin and Ethereum and some of the older coins. Proof of stake is a little newer and it's more efficient. It's not as energy intensive. So in proof of work, essentially what's happening is that the computers are guessing new hashes for the blocks until a valid hash is found. So pretty much brute force guessing these really complex math problems. In proof of stake, you lock up your funds in a wallet, and typically you'll agree with other validators on what transactions to include in a block and then you receive a portion of the transaction fees. And in mining, after you mine a block, you receive what's called a block reward. And this is how new tokens are introduced into the supply. So in proof of stake, when you have a very large amount of value locked into like a proof of stake protocol, the system kind of becomes this playing field of game theory and financial incentives. So proof of work and proof of stake are the most common, but there are more examples of consensus algorithms. Like there's delegated proof of stake, there's proof of authority, but because these are the main ones, most of the cryptocurrencies today are actually built on proof of stake. Again, just because proof of work is very energy intensive. And on the right, we have some examples of blockchains that are proof of stake. Cardano, Polkadot, Solana, Cosmos. And then proof of work, we've got like Bitcoin, Ethereum, Dogecoin, and Litecoin. So layered solutions. So the problem that we have is that there's what's called a blockchain trilemma. So on this pyramid, you can see that we have three aspects. We have security, scalability, and decentralization. The reality is that you kind of have to pick a corner of the triangle. You can only have two out of the three. So you have to pick either security and scalability or decentralization or scalability. But security and decentralization are usually considered non-negotiable. So for scalability, there are layer 2 solutions that are built. So layer 1 solutions, this kind of refers to the blockchain, and layer 1 scaling solutions may augment the base layer of the blockchain protocol by changing like the rules of the protocol. And you can build blockchains on top of blockchains. And so, but the layer 1 is responsible for the settlement of the transactions. And layer 1 is also like an example of a scaling solution for a layer 1 is like increasing the amount of data in the block, increasing the rate at which a block is confirmed, things like that, but rules of the actual protocol. Versus layer 2, we have third-party scaling solutions that are kind of like used in conjunction with a layer 1, and it operates on top of the blockchain protocol. So what happens is it kind of like redirects the transactional load to an adjacent system architecture. This architecture handles the processing and then submits cryptographic proof that the load has been processed and then reports to the main blockchain to finalize. And here we see things like nested blockchains and side chains. And some examples are Polygon. So a lot of people refer to Polygon as a layer 2, but it's actually an EVM, Ethereum virtual machine compatible sidechain. So the lines aren't really that clear cut because some people think because Polygon is a third party, it's a layer 2. Some people think it's just, since it's EVM compatible, it's just a side chain. Another example is Bitcoin's Lightning Network, which handles like almost instantaneous settlement of the transactions. And another thing I want to talk about is Ethereum 2.0. So right now, Ethereum, the consensus algorithm is actually based on proof of work, and there are miners, but they're actually upgrading Ethereum to be a proof of stake. And that is what's called Ethereum 2.0. It's just going to be the same blockchain. It's just going to be like an upgrade. Okay, now that we've talked about the technology behind the blockchain, I want to talk about the cryptocurrencies of each blockchain. And this is what we call tokenomics. And I'm sure you've guessed it's combined with the word token and economics. So from tokenomics, we can kind of evaluate like the short-term performance of the market, determine like future worth, or maybe get an insight into profitability. So the first part is market cap. So market cap is the entire amount of funds that have been invested in a project so far. And we calculate this by taking the market price and multiplying it by the circulating supply. And this is kind of similar to stocks. So I know that a method of valuating a company is you take their share price and then you multiply it by the amount of available shares. So it's very similar. And the fully diluted market cap, this is the theoretical market cap if the maximum supply of the token was already in circulation. And some questions that help us understand this is like, what is the total value of the currency? Distribution of tokens. So distribution of tokens is also really important. Some things that you have to consider are like minting of new tokens, like how many tokens are rewarded to miners or validators. Are there any tokens set aside for new developers? Did the protocol give most of the tokens to the community? Things like who owns the coins. And one thing that we can look at is called the initial coin offering. And this is really similar to like an initial public offering when you raise funds for like a new company, except initial coin offering, you're kind of like crowdfunding a new cryptocurrency. So supply and demand. So I want to talk about the differences between the available, the circulating, and the maximum supply. So the available supply is the total token supply, the number of tokens that exist at the present. And then the circulating supply is the number issued so far and currently in circulation. For example, if you're staking your coins, then those coins are not considered in the circulating supply. Maximum supply is the maximum number of tokens that can ever be generated. And some questions that help us understand this is, how many tokens exist now or will exist in the future? Lastly, the protocol token model. So every blockchain protocol kind of has like a different model for how they release tokens or how many tokens they release. Another thing you have to look at is this token model inflationary or deflationary? If it doesn't have a maximum supply and will be continued as time goes on, then we can kind of consider it inflationary. Versus deflationary, it's a little safer to assume that the cryptocurrency will be valued more as time goes on. So some things that help us understand this part is, how many tokens are going to be minted, how many will be burned, lost, or somehow unusable. And an example I want to give for this is Bitcoin. Bitcoin was just hard-coded to be capped at 21 million tokens. And this is just what Satoshi said in the code. And right now, over 90% of the supply has already been mined. So a little bit less than 10% is left. And we talked about mining and the block reward. And here in Bitcoin specifically, Bitcoins are released at a rate that gets cut in half about every 4 years or so. So the mining reward gets cut in half. So as time goes on, as the rest of these 10% of the tokens are released, we shouldn't really expect any serious inflation because most of the supply has already been mined. Okay, so now that we've talked about the blockchain and the technology and the network, what are some other external factors that affect the price? So social media has a lot to do with this because Bitcoin is still considered like a speculative asset. So there's a lot of fear, uncertainty, and doubt. When a lot of people see the markets tanking, they get really scared and they sell. Or there's a lot of rumors, fake news that the news and media kind of affect the price, and then also celebrities and people with influence. For example, Elon Musk, sometimes when he tweets about Bitcoin, the price will jump up. Another thing is government regulation. So there's just varying monetary policy by country. And for example, El Salvador recently legalized Bitcoin as legal tender. But on the other hand, there's also bans. For example, China banned Bitcoin miners, so miners had to move out of China. Another thing is looking at the macroeconomic markets. The price of Bitcoin and Ethereum are actually highly correlated with the equity markets and like the health of the global economy and the stock markets, and also have something to do with the inflation rates. Another thing is the cost of production. So the volatility is kind of linked with the cost of production, like how expensive is it to mine Bitcoin? And one thing that factors in here is the value or the price of the technology hardware that these companies sell the hardware for. And lastly, some ESG concerns. We're going to talk a little bit about the energy market. I actually have a slide on ESG concerns here. So some concerns are the environmental. So Bitcoin actually uses more total yearly energy than some entire countries. And I think I saw somewhere that over 50% of the energy used in Bitcoin is actually from renewable and non-fossil fuel resources. Also, Christmas lights and dryers and AC units use way more energy than Bitcoin. So when people see that Bitcoin kind of uses more yearly energy than some entire countries, they kind of get a little skeptical. But also, proof of stake tokens are not as energy intensive as proof of work tokens. So yeah, and some social things. So Bitcoin is kind of like a lifeline, a protest, and a way out for billions of people who cannot escape their country's exploited monetary systems. A lot of countries have currencies that don't really fulfill what a currency is supposed to do. There's like really high rates of inflation. There's not a lot of financial infrastructure there. So it's a really equitable form of money that can be used for these kind of people and people who need some sort of financial infrastructure or payment gateway. And governance. So this is kind of so we call this like rules without rulers. Government leaders and large financial institutions can't really control the rules of Bitcoin or its implementation. Bitcoin is borderless, it's permissionless, it's non-discriminatory, and it's censorship resistant. So it's a lot of power to the people and not like big authoritarian governments. And lastly, I have some summary and key takeaways, what we just talked about before. So Bitcoin is a decentralized currency and a speculative asset. It's a peer-to-peer cash system versus Ethereum is just a general purpose programmable blockchain. Consensus algorithms, they cryptographically secure the blockchain. In proof of work, we have mining versus in proof of stake, we have validating where you like lock up your tokens. And then the blockchain trilemma, where you can only pick 2 out of the 3, scalability, security, or decentralization. We also talked about some tokenomics, the supply, demand, distribution, and some things about the token protocol. We also talked about some macroeconomic factors, the global health of the economy and other markets. And lastly, we talked about some environmental, social, and governance impacts. So yeah, that's actually all I have today. I got through it a lot quicker than I thought, but that leaves a lot of time for questions. So if anyone has any questions, I'm happy to answer.
Yeah, thank you so much, Ivy, for taking us through this presentation. We've already got a number of questions that we can maybe go through together, and we're still open to questions. If anyone has questions, feel free to post them either on LinkedIn or on YouTube, depending on what platform you're using to watch us. A first question here that we've got from Tech is, one challenge raised about blockchain applications for transactions has been transaction processing speed. Is that still applicable?
Yeah, so that's actually part of layer one solutions. So when we talk about layer one solutions, this kind of relates to the blockchain protocol directly. And one of the ways that you can increase the overall throughput is what I mentioned earlier, by increasing the amount of data in the block or increasing the rate at which a block is confirmed. The primary characteristic of layer one blockchains are actually their consensus algorithms. So doing changes to the consensus algorithms directly is considered a layer one scaling solution.
Great, thank you. So solving both for the environmental challenges and the processing speed as well. Another question that we've got from Sharif is actually how new tokens are generated and who takes the proceed from selling new tokens.
Right. Okay, so in mining or in proof of work, the new tokens are generated because the miners are validating these transactions, and then the protocol gives them a reward. So after they mine a block, you get XX a number of Bitcoin, and then those miners are the ones who have the rights to sell or introduce those tokens into the market. That's proof of work. In proof of stake, these new tokens are generated by validating new transactions. Proof of stake, I will say, can be a little inflationary because when you are validating these new transactions, you get rewarded with the new tokens.
Great, thank you, Ivy. We've got also another question from Hiam asking if we have any Finastra application already developed for Bitcoin management. And here, what I would suggest is actually, if you can go and check fusionfabric.cloud, which is our open development platform. There is also a marketplace, and you would be able to see a number of partners that we've been working with that offer either Bitcoin or crypto investment solutions. And just to name a few, we're working with Allied Payments, Back, Liquid, Sequoia, and others. So you can go to fusionfabric.cloud and just search maybe for Bitcoin or crypto, and you'd be able to check that. Another question that we've got earlier from Jose is if you can please touch up on how we can buy Bitcoin digital tokens without a bank account.
Actually, I'm actually not too familiar what it's like outside of the United States, because the United States has pretty strict regulations, especially with anti-money laundering and KYC. So here, it's really difficult to buy without a bank account because you have to go through an institution that does the KYC protocol, and so you do need a bank account. I'm not sure how it works in other countries, but I know that all you have to do is just open up a wallet, a decentralized wallet, and in order to fund the wallet, you have to go through like an exchange. But again, the exchanges in the US are regulated, so I'm not sure if I can really answer that question.
Yeah, maybe just to add on the way it works here in France is that you can either use your bank account or a credit card, and you need somehow to go through a central exchange to get started. So yeah, that's what I've seen so far. We've got a number of other questions. So many questions here. Thank you all, and keep them coming. We'll try to cover all of them.
Sorry, one thing I wanted to mention is I've seen around some places around where I live is when you could go to the gas station, there's like Bitcoin ATMs. And I think that you can just deposit cash and then it'll or connect your wallet and then send it. I think that's one of the ways where you can buy Bitcoin without a bank account.
Thank you. We've got some philosophical questions, I would say, coming up. Let's try to cover some of these. So we've got a question. Let's start with this one. Not really philosophical here, more of a practical question from Mael about energy in Bitcoin. Do we have any idea how it compares with Swift system from an energy consumption perspective? Any thoughts on that, Ivy?
I'm not sure if I can answer that just because I don't really know how much energy Swift systems use.
Yeah, sure. So maybe, Mael, what we will do is check that. I'm sure there are some comparisons out there, and we'll make sure that we get back to you on LinkedIn. We have a number of other questions actually on central bank digital currencies. So first one, and I'll share it here from Varun, is about how CBDCs will impact the current cryptocurrency and current trails, such as Swift. And we've got also another question that is quite similar actually from Sushma, who's asking, what is the future of cryptocurrencies given that central banks of many countries are banning them and coming up with their own versions of digital currencies?
So I will say that it's really, really difficult to outright ban a cryptocurrency. In order to shut down a cryptocurrency network, you would have to shut down the entire internet across the world, because there's thousands of computers with the same copies of the same data. So in order to take down the network, you'd have to shut down maybe over 51% of all of them. But given that there are countries that are putting bans, I think that, I think that they will exist alongside each other just because it's really difficult to ban them. But also these digital currencies that are being implemented by other countries are, I think it's pretty much the same concept, except that it will just be a little more centralized. Yeah, I'm not sure if I have.
Yeah. I think it's definitely a difficult question. We don't really know how the future, how both stable coins versus CBDCs will evolve in the future. That's definitely a space to watch. Lots of similarities, of course, as you mentioned, Ivy. CBDCs would be much more centralized. Even though they could be somehow decentralized in a way, if they are evolving multiple players, different banks alongside the central banks on a given country. So, yeah, it's definitely the early days there, and a very interesting space to watch. Another question here. From Florinash, are there any known big players on the Bitcoin and Ethereum markets who could drive the price up or down based purely on their buying or selling power? And so, yeah, back to the economics aspect.
Yeah, actually, yes. In the cryptocurrency world, we kind of call this term whales, and whales are individuals that control a really large amount of Bitcoin or Ethereum or whatever the cryptocurrency is. And although they do have such a small share of the total supply of, let's say Bitcoin, there's a supply of 21 million, almost 21 million tokens. Although they have a very small share out of the entire supply, it is possible for them, if they were selling a big portion of what they have, to drive the price up or down.
Great, thank you, Ivy. And we'll just take a One final question here. We'll definitely take all the others on the LinkedIn chat or YouTube, as we probably won't be able to take them all. Here, a question from Varun. Can you give examples on how Finastra is looking to utilize some of the core fundamentals of the blockchain technologies within their existing suite of solutions, such as payment hubs, etc.? And I think this one is a really interesting one, Varun. I will just use it as an opening for segue to our hackathon again. We definitely believe that blockchain, crypto, DAOs, Web3, NFTs, and lots of the innovations in this space can be really interesting from traditional finance perspective, whether it is for payment, trade finance, capital markets, and probably much more applications. We will be leveraging the hackathon here as a platform to explore some of the possibilities. We will continue with this live meetup format with more speakers. We'll be having another session this Thursday with Sylvain Prigent from Société Générale Forge, who's the SocGen arm, actually focusing on securities tokens and digital assets for the capital market space. So that's one possible applications of the technology in the capital market space. We'll be having other sessions with players like Defactor for trade finance, or DeFi Pulse for everything around investments, and DeFi protocols, how to bring them to traditional finance. So definitely lots to come on that. We'll be exploring it with different speakers. We'll be also hosting design thinking sessions that are open to all. You'd be able to register to that. And hopefully, as we work on this hackathon all together, we'll be able to see lots of new use cases and new innovations coming in the payment space, but also in trade finance, corporate banking, investment, capital markets, and much more. I'll just add here the link about the Hack to the Future hackathon. You will find more information as well as more details about the upcoming events there. And with that, I would like to thank you very much, Ivy, for a very insightful session. And this is just the start, so definitely we'll continue the discussion. Everybody, please feel free to connect with Ivy or myself on social media, for instance. Please join our next sessions as well. As I mentioned, Thursday, we'll be speaking with Sylvain Prigent about securities tokens and how DeFi is transforming capital markets. Tomorrow, we'll have a different session, a FICA session on the Finastra page with Anita Lee, who's a previous hackathon winner, and much more content coming up. So check the hackathon info and events on the finastra.com hackathon page. Thanks a lot, Ivy, again. And thank you very much, everybody, and see you soon.
All right, thank you guys. I just want to also say that I am doing another session, but it won't be a live session. It's going to be recorded, and this one will be how to set up your first Ethereum wallet. It's called MetaMask, and how to use the MetaMask with other decentralized applications like OpenSea, or things like Compound Finance. Once you open a MetaMask wallet, it's really, really easy to utilize the other blockchain technologies. So I hope you guys join that session, or I hope you guys also watch that session. I'm thinking that it'll be ready by the end of this week.
And we'll definitely share it on LinkedIn here, so you'll be able to check it. Thank you so much for mentioning that, Ivy. Forgot about it.
All right. Thank you, everyone, and great questions.
Yeah, thank you, everyone, and see you soon. Thanks, Ivy.